Good afternoon. Oh. Good afternoon, friends. There we go. That's better. Thank you for humoring me. So welcome to a session about understanding execution plans. A few slides that you've already seen, you'll continue to see. Please make sure your cell phones have been silenced. I'm happy to answer calls, just not in the middle of the session. There's a ton to offer while you are here at Summit. I definitely hope you take advantage of it. I have been coming to this conference since 2010. If you have questions about this conference, about PASS in general, feel free to come up, talk to me afterwards. Happy to answer and give my perspective. This is the yay me slide. My name is Erin Stellato. I am a consultant for SQL Skills. My email address is the most important thing on that slide, erin@sqlskills.com. If you have any questions related to this session that you don't get answered today, feel free to send me an email. I also have business cards that I can pass out if you're interested. I'm on Twitter @Erin Stellato, and my blog is listed up there as well. And as a reminder, this session is part of we're kicking off, actually, the Developer Learning Pathway. Now, if you're not a developer, that doesn't mean that you can't be in here, obviously. But there's 2 additional sessions in this pathway. Right after this one, Bert will be talking about indexes. And tomorrow, Jonathan, who is my coworker, will be talking about anti-patterns and RBAR. So, again, if you are not a developer, that's cool. But I'm expecting that if you're here to hear about execution plans, it's because you don't have a ton of experience with execution plans. If you have worked with them for a long time and you're really familiar with them, this might be too simple for you. And if you want to go, I'm not offended in any way, shape, or form. But this is the abstract, and I'm assuming that you've all read it. If not, go quickly because I'm moving on. Because I want to dive right in and start talking about the value of execution plans and why we care about them. So the most frequent email that I get from customers is, we're having performance issues. And I'm sure that most of you are familiar with this type of discussion. And when they reach out about a performance issue, the typical complaint is, it's slow. Right? You've heard that before, correct? Okay. And so understanding what slow means is dependent upon what I think is slow and what the user thinks is slow. But have you ever noticed that nobody ever comes to you and says, this query, it's taking way too much CPU, right? No user ever says that. No user's ever like, there's a lot of I/O going on in the background. Or maybe they're complaining about a memory grant. That doesn't happen from the user perspective. All they care about is how fast the thing goes. But there's a lot that goes on behind the scenes. And if we think about performance, and if we think about looking at query performance overall, there's a ton of data within SQL Server that we can look at. We can look in the DMVs, right? These have been available since 2005. There's a ton of DMVs that are available. There's probably 4 or 5 that I tend to focus on when I'm looking at performance. I also will use extended events, or if you're old school and still on older versions, you might also use trace. It's great for looking at individual query performance. We also have one of my very favorite features, which was added in SQL Server 2016, which is Query Store, which gives us great history about query performance. And then you might have a third-party monitoring tool, which can definitely make your life a lot easier. You might have set up, you or your developers, depending on what role you're in, you might have set up custom logging within your application to try to track where things are slow, what's going on. And of course, we have execution plans, which is our focus today. So we could talk about all of these, but again, our focus is really on those plans. And every single query that you send over to SQL Server goes through compilation, goes through optimization, and a plan is generated for that query. So there's a lot that happens behind the scenes that sometimes I think that we don't think about, right? All we think about is we wrote the query and we get the results and is it fast or slow? But there's a whole bunch of stuff going on with the optimizer and the engine that we don't always consider. And I also think that's true when folks write T-SQL. Right? When you write T-SQL, you're basically saying, this is what I want you to do, SQL Server. I want you to go select this data and this data from these 2 different tables where it meets this particular criteria and bring it back to me. And that's all you're usually telling it to do. And so SQL Server then decides how that's going to happen. And there's always exceptions, right? I know there are some folks that absolutely love their hints, or sometimes you really try to use a plan guide to guide the optimizer, right? This is what I want you to do. Or in Query Store, we can force a plan to say this specifically is what plan I want you to use. The plans are helping, the purpose of that plan is to help us understand what the optimizer did. How did it decide to go get the data from those two tables based on the predicates and return it back to us? So just to make sure we're all on the same page to start, a very simple plan. And I want to make sure that we're all familiar with certain items here. So in the very top far right of that plan as you're looking at it, we have an operation. It's a data access. We're accessing the address table, a specific non-clustered index against that. And we're pulling data out of it. And the data goes basically the flow of those arrows. And after that, after we access that index, there's a sort that occurs. A sort means we're going to order the data in a particular way, right? And that feeds into part of our join. And in this case, we're joining three tables together. We're joining address, we're joining business entity address, and we're also joining to person. So if you look, index scan goes against address, our table or index scan kind of in the middle goes against business entity address, and then down at the bottom in the middle, we have a clustered index seek against person. So we can see that we are accessing those three different objects. And we obviously have to join those tables together. And so the joins that we see in the plan, we see a merge join here between the business entity address and the address table. And then over to the left, right before that select, we have a nested loop. That's the join that occurs between the person and the output from the other two tables. So when I'm talking about object access, I'll say data access sometimes, and I'll talk about the index or the table. But for the most part, just as a heads up, I'm going to defer the index material, the internals of the indexes, to Bert, because that's really what he's going to cover in his session. So I'm kind of setting him up to give you guys background about execution plans, so that when he starts to dive into the indexes and goes into plans, you'll be able to pick right up where we left off at the end of today, or the end of this session, excuse me. But I do want to talk today about those joins that occur and what operators we see. And I'm also going to mention a little bit about sorts. And we're focusing on selects, because a large majority of the queries that I have to tune, and I suspect you have to tune also, are related to selecting data out, right? Not related to inserting, updating, or deleting. Those sometimes do need to be tuned, don't get me wrong, and they have plans as well. But today we're focusing really on the select, right? Pulling that data out. Now, how do we find our plans? This is, I think, incredibly important, and I want to lay the groundwork for this because I think it's really important when you're talking to other people about your plans. I want to make sure that we're clear on what type of plan we're talking about and where we get it. So after a plan is generated, right, after we go through compilation and optimization and a plan gets created, that gets put into the plan cache. And notice that I have an asterisk up there because there's exceptions. There's always exceptions, right? Not diving into that today. But for the most part, you can go to the plan cache and you can find that particular plan. And ideally, that plan is reused. And I say ideally because for those of you that might have been in my Query Store session, or for those of you that have ever heard me talk about ad hoc queries, a query that is not parameterized, a query that has different literal values every time it's executed. Those queries, if you have hundreds of thousands of users running those types of queries, every time they're submitted, they have to go through compilation and optimization and they get put into the plan cache. And there's problems related to that because there's some CPU that's required there and there's time that's required. And then we put it into the plan cache, and if we have hundreds of users executing thousands of queries throughout the day, then the plan cache gets filled with all these plans that are only used one time. So ideally, I have a plan that gets generated for a query that's parameterized, and it gets reused over and over. Now, there's always caveats again, right? There's always exceptions. So there's cases where that might not be ideal as well. But in terms of looking at these plans, besides the plan cache, we can also get them from Management Studio and Azure Data Studio. I'll focus today on Management Studio because I tried to do some stuff with ADS and I couldn't quite get it to do exactly what I wanted, so I stuck with SSMS for today. But I really like what's going on in Azure Data Studio, and I suspect a lot of you will see it in different demos throughout the week. Plans are also captured in Query Store. So if you're 2016 and higher and you're using that, you can go grab plans from Query Store as well. And you can use extended events or trace. And I don't recommend this for either one because of the overhead that it requires in order to capture those plans. So now what kind of plan is it? And this is where my friend Hugo and I have some differing opinions, but it's all a good thing because I love that we talk about this. You may have heard the concept of an estimated plan. And you may have also heard of the concept of an actual plan. And you may have also heard, I didn't put it up here, the concept of an estimated plan with runtime statistics, or the estimated plan with actual execution statistics. And I propose that there's a slightly different way to talk about this, which is the used plan. The plan that gets used, the plan that's in cache. And I'm gonna show you what I mean by all of this. So we're gonna go into Management Studio, and we're working with, I have multiple databases on here, but we're working for this first demo with a copy of Wide World Importers, which is a Microsoft sample database that you can download from GitHub. And I've done a little bit of prep against that, but I want to make sure that I have Query Store enabled. And we're also going to clear out anything that's in Query Store. Now, if you have Query Store, this isn't something you want to run against your production environment because it purges all the data. That's not a great thing. So we're going to make sure that we set the context to our Wide World Importers database. And those of you in the back, to make sure you're still awake, you can see this okay? You can see the text? Okay, head nods are good. Thank you for the thumbs up, appreciate that. And I really know you're awake. And we're gonna take this first query. You're gonna see this query a lot, so I'm gonna take a second just to walk through it. We're selecting the customer ID, and we're doing an aggregate on the amount excluding tax from the customer transactions table. And in this case, I'm specifying customer ID 401, and then because we're doing that aggregate, we're gonna group by customer ID. And what I'm gonna do first is I'm gonna ask the optimizer to give me the estimated plan. And so all I do is I come up here to query, and I say display estimated execution plan. And before I do this, let me make sure that I have Zoom it running so that nobody yells that in the middle of my presentation. Not that any of you would do that. But underneath query, we're gonna go display estimated execution plan. And this does not actually run the query. Goes through and it does compilation optimization, but it does not give me any output. It doesn't run the query. I don't see anything in the output. It just says, here's what I think I'm gonna do. So I can look at this, and if I hover over this, I see that first of all, we are reading through that entire clustered index. And I can also see from this, just as a heads up, that this is a parallel operation, right? So anytime you see the circles with the double arrows in that, that means that this query is multi-threaded. It's running in parallel. And that's an important thing to note. If you have a purely OLTP system, which I don't see too much of these days, but if you have a pure OLTP system, you're doing short, fast-running queries, and I suspect most of those are single-threaded and run sub-second. But what happens very often is that people want to see more than just those single-threaded queries, right? We decide that we want to read some data out and we want to do some reports, and before you know it, you've got these big queries that are also running against your OLTP system. And those bigger queries, they might not run so well single-threaded, but if you run them multi-threaded, right? If you run them with parallelism, they're great. So when you look at a query plan, one of the first things you might notice is whether or not it's serial or it's running in parallel, and ask yourself, is that a good thing? Is that what I'm expecting to happen? So I can see that that's going on here. And when I hover over this, the other thing to note is that in terms of how many rows it thinks it's going to return, I have that, right? It says estimated. How many rows do we think we're going to get back from this? And it says, well, we're going to get quite a few. Right? We're going to get 11 million back from this. Okay. So the estimated plan here is what SQL Server thinks it's going to do. And most of the time, the estimated plan matches up with what it actually does, but not always. So it's not a guarantee. So just because you have an estimated plan, it doesn't mean that when you run the query, you will always have that exact same plan be generated by the optimizer. But this is what I call the estimated plan, because we've just asked what it thinks it will do. So I'm going to run this query just for fun. I'm not asking for anything related to the plan, and it runs in about a second, okay, for it to complete. Now what happens here, and I'm going to run both queries together, and I'm going to, this time, include my actual plan. So this is a different option. And when I select this, nothing will happen initially until I run these queries. And notice that I have two different input parameters. I have a value of 401, and I have a value of 1092. So we're going to go ahead and run both of those. And when we look at the output here, we can see that, first of all, it actually executed our query, so we get the results back, different than the estimated. And when I look at the execution plan, I have two different plans. So same exact query, two different input parameters, and I get two different plans. Because this is what we call a parameter-sensitive query, right? I have a very skewed distribution of customer IDs in this customer transaction table. I'll tell you that for the values of 1 and 401, I have like 10 million rows each. And for everything else, I have just a few thousand. Okay? So large skew. And I find that this happens a lot in customer environments, right? Have you ever had this scenario where things are running really, really well, and then someone calls and says, I don't know what happened, but this query just tanked. It was running really great earlier today, and now it's not running well. And then you do something and you're like, maybe I should update statistics. Maybe those are out of date. So you update statistics and then everything works again. What actually happens when you update statistics is you can force the plan to recompile, which basically says the next time that somebody runs it, take whatever input value they've used and generate that plan with it. And so maybe then you end up getting the good plan back in cache again. And yeah, I'm going to show you how this works here with this exact query. But understand that with my two different values, I get two different plans. But in this scenario where I have the actual plan, if I hover over this clustered index scan, and understand, this top plan, that is the same one that we saw for the estimated, right, for the value of 401. So if I hover over this clustered index scan now against that table, notice that in addition to my estimates, I also have my actuals. So I refer to this as the actual plan. It has the estimates for what the optimizer thought it was going to do based on statistics, based on the cardinality estimates. And then it tells me also what it actually did. And in this case, my estimate and my actuals are pretty close. And if we look at the plan below, we can see that it just still accesses the customer transactions table. But down here we have a seek. That's how, I'm no good as John Madden. That's how it gets the some of the data, and then it doesn't have everything that it needs from that object, so it goes back to the table and it does a key lookup. Okay, and if we look at this estimate here, where we say, how many rows did you think you were going to get in this data access? It estimates 4,800, and it actually returns 39. So just hovering over the properties of the operator gives you a ton of information, right? So a couple things to note. I keep referencing what the object is, and it tells you that exactly right here. It also tells you what columns it's pulling out from that object. And then, depending on what your predicate is, if it's a seek predicate or just a predicate, it will give you that information. So this is exactly where I said I want customer ID equal to 1092. And then because that index didn't have all the columns I asked for, it had to go do this key lookup against a different object, a different index, And you can see here that that column that it pulled is that amount excluding tax column. When it went to the clustered index and it scanned it, right, it had everything that it needed there. So interesting things about these two plans. Notice that the top one is parallel, the bottom one is not, right? We don't see any parallelism operators in there. And you might also notice that we have this missing index recommendation. The optimizer says, you know what, it'd be really nice if you had this index instead. And I pay attention to those missing index recommendations. Now, if I run 10 different queries against the same set of tables, and I get 10 different missing index recommendations, I'm not thinking I'm going to create all 10 indexes, right? What's the right number of indexes to have on a table? Yes. As many as you need. That's a fantastic answer. I will buy you a cup of coffee. As many as you need. Indexing is an art and a science. And again, go to Bert's session because he's going to talk a lot more about it. In this case, maybe I will create the index for this to satisfy it, but it only recommends the index for this query. Right? So understand that about the missing index recommendations. I tend to take those. I look to see what indexes already exist on the table. Does it make sense to add another one? How frequently does this query run? If it's only once a day, maybe I can get by without that index. If it executes 100 times a minute, maybe I do need it. Maybe it does make sense. Maybe it's worth the overhead. But remember, in general, we want to do some type of analysis before we add those. But missing index information in the plans is worth paying attention to. And the other thing I want to point out real quick in these two plans is my cost, which specifically I'm interested in the cost for each one of these. So because I ran both of these together, it gives me the cost for each of them. And it basically, in this case, totals up to 100. Usually it always totals up to 100, but there have been some bugs sometimes where I see that it goes above that. But I look at this and the cost says that that top query is a little bit more expensive than the bottom one. That's fine. Now we're going to take this query because it's something that runs a lot and because I don't want it to compile every single time somebody runs it because it runs 100 times a minute, and we're going to put that into a stored procedure. So we'll create a stored procedure called customer transaction info, and it has our exact same query in it. It's just that we've parameterized the customer ID. So we'll create that. And for fun, I'm going to create an event session, extended event session, that captures statement information, and it also captures query post execution show plan. Now, this event session is just for demo purposes. The overhead of adding this event to an event session in production is prohibitive. You can definitely introduce performance issues, so I do not recommend that. Just want to make that clear. I should probably add some notes. That would be a good thing, right? And we'll verify that we've got query store enabled. I turned it on, but let's just double check. We're in a read-write state. Perfect. Now, another do as I say, not as I do. I'm going to dbcc free proc cache. And even worse, I'm not even specifying a database. I'm just removing the procedure cache for the whole instance, right? Getting rid of all the plans. Not good. But today, I'm not so worried. And we're going to start my event session, so that's running. And I'm going to open up, we're going to look at live query data, just so that we can see what happens as it happens. So let's refresh this. We've got query perf, watch live data. And I'm going to take this query right here, and I'm going to paste it into another window. And I'm running statistics IO and statistics time. I'm turning both of these on, as well as the actual plan. So I can turn on the actual plan both from the query menu and also using set statistics XML on. And then we will run our stored procedure one time. So let's do this and make sure we're in the context of the database. And then we'll go ahead and run our stored procedure. And then I'm going to stop my event session over here, or stop capturing data. And I want to take a look at what we get in the different places in terms of our plans. So again, I ran this query with the execution plan, with the actual plan enabled. So if I click on that link, that actual plan is going to pop up, and it's going to look just like the one we had generated with the literal values, with the 1092 as a literal value, right? We have an estimated number of rows here, and we have an actual number of rows displayed here. So there's the actual plan. Now let's see what happens if we look at extended events. So here's the query that we executed, and this is the plan for that query. And this is going to be down here in XML format, which is very useful. But for the moment, if I want to view this graphically, I can say File, we're going to save that, we're going to just drop that onto the desktop and call it our plan. So that saved as an XML, which is not what I wanted, so let's try that again. Let's save this, and we say all files, and we're going to put a SQL plan as the extension. I'm going to hop out to the desktop, and I'm going to open a different tool because I want to give you an option in terms of looking at plans. I'll spend most of today in Management Studio, but just so you're aware, there is a free tool called Plan Explorer, which is from SentryOne, who's a sponsor here at Summit. And this is a really nice way to look at plans. So let's open up our plan and drop it in here, or over this way. So the thing that I like about, there's a lot of customization, which I'm not going to go into at this point, but it's another way for you to look at plans, and sometimes it's a little bit easier. For example, when we looked in Management Studio, in order to look at the differences between our estimated number of rows and our actuals, right, I had to hover over that operator and get the pop-up to see the difference. Here, one of the things that I can do is I can go into top operations, and notice right here, I get this lovely list that says, here's the estimated number of rows and here's the actual number of rows. And I can really quickly see where that disparity exists. Right? So it makes it a lot faster for several different troubleshooting options with Plan Explorer. But let's hop back here. So that's the XML plan. And what I wanted to point out was here in Plan Explorer that we also have our actual and our estimates. So from extended events, I was able to capture the actual execution plan for a query. But again, very expensive in terms of the overhead that consumes. Now what else do we have? We also have the plan cache. And here's the query that we can use. We're going to go against dmexec query stats, and then I'm going to join over to dmexec SQL text and dmexec query plan, specifically looking for queries that have this text in it. And if you have a very large plan cache, this query can take a while to execute, so be aware. This is pretty fast in my environment. And if we look at this plan, this is a plan that's in cache, and if we hover over this and we zoom in, you'll see that we just have estimated values. But I call this plan the used plan, or the cached plan, right? It has estimates because when SQL Server looks at that query and it looks at the input values that you have, it estimates how much data it's going to return, right? What these operators are going to have to do. And it puts that information into the plan, and that's the plan that goes into the plan cache. So when I say the used plan, I mean the plan that's in the plan cache, or the plan that's in Query Store. So if we come back to this window and we scroll down and we look in Query Store, and I'm going against the Query Store objects here and looking for this particular stored procedure, the plan here that's in Query Store is exactly the same as the one that's in cache. It has our estimates. It's the plan that was used. So estimated plan, we get from Management Studio and we say display estimated plan. Actual plan, we get from Management Studio and we say display actual execution plan, or we can get it from extended events or trace. And then the used plan is what we get from the plan cache or from Query Store. But we're not done yet. You're like, really? There's more? Oh yes, friends, there's so much more. We also have the ability to look at live query statistics. So when we're running a query for Management Studio, sometimes you have a query that takes a long time to execute, but you don't know why, right? So if we execute this, sales, our stored procedure, with a value of 401, right, you can see that we're at 8 seconds, 9 seconds, right? When we ran this before, it didn't take very long, right? It took like a second. And now it's taking 20, 22, it's taking a long time. And at this point, if you go back to the plan cache, right, okay, that's great. If you go back to the plan cache, you're going to see this plan. This isn't the same plan we saw for 401 before. And sometimes when you're doing this, it's not that it takes 28 seconds for the query to finish. It takes 5 minutes. It takes 50 minutes. And I don't know about you, but I'm not very patient. And I don't want to wait for that thing to finish. So you have a new option in Management Studio. And I'm going to turn off actual execution plan. And I'm going to say include live query statistics. And so we'll start this up. And what happens, and I'll zoom in here, is you can see that it's giving me an update. So it's moving the data through the plan, and it shows you where it's coming from. So I can see that I have data coming out of this non-clustered index, and I can see that there's a key lookup, and I can see that the numbers are way higher than they were when I looked at this index seek with the key lookup before. So what has happened, right, is the first time I executed that, and now it's finally finished. The first time I executed that stored procedure, I executed it with the value of 1092. That was a pretty unique value. So because it's a parameterized query, it's part of my stored procedure. It generated this plan. It put that plan in cache. That's my used plan. And it's going to continue to reuse that. Now when I run it with 401, that is not an efficient way to go get that data for 401, but that's the plan that's sitting in cache. So it's going to use it. Does that make sense? So this is that parameter sensitivity problem that we often see, where we have the plan that's really good and things are great, and then all of a sudden for a particular value, maybe it doesn't run so well. Now I have one more option in 2019, which is pretty cool. I'm going to make a change here, which this change will clear the plan cache. And we're going to say alter scope configuration, set last query plan stats on. So what this option does, I'm going to turn off live query statistics. I'm going to rerun the stored procedure with the value of 1092. So this comes back really quick, right? Less than 1 second. And now I'm going to check this new DMV, DM exec query plan stats. I have to pass in the plan handle. And when I look here, and I open up this plan, what I have, and this is coming from a DMV, I have a plan that has both estimated numbers and actual numbers. So what's in this DMV is the last run of that plan, the last execution of that plan, with the actual execution statistics. So if this is a query that executes a lot, it's who knows what I'm going to get, right? I may see this plan, or when I come in here and I run that other variation, right? When I run it with the value of 401, and this is going to take a while, and then I go check when this is finished, what I should see is I'll see that index seek with the key lookup. I'm going to see that exact same plan, but now I'm going to see the estimated values and the actuals, and I'm going to see that there's a big discrepancy, right, in those estimates because I had such a different input value. So when this finishes, and we get our data back, we'll go ahead and check to see what's here. And now, right, you can just see that this, even though it's the same shape of the plan, my lines here are a lot thicker, right? So I definitely have more data that's moving through the plan. And when I hover over that index seek, I can see that my estimated number of rows 4,800, my actual number of rows, 11 million. Right, big difference. And as a reminder, I keep hovering over the operator and getting this pop-up window. But in case you're not aware, if you press F4 on your keyboard, you will get a properties window that pops up as well. And information that I get from that pop-up also shows up over here on the right side. And I get different information for each of those operators. Now, the thing that's really interesting here is that when I come into this query, I can see that the actual statistics are different. And remember when I looked at the seek predicate and I could see exactly what the value input was? All I get here is that it's the customer ID. And if I come over to my select operator, if I click on that, one of the nice things that you get in the plan is you get a parameter list. But these are the values that the plan was compiled with. So that's not the most recent executed value, right? I executed it with the customer ID of 401. It was compiled with a value of 1092. But that's still really useful because if I have different plans for the same query, one of the first things that I tend to do is I go look to see what values were used for compilation. There's a question. I said that the cached plan, which I also call the used plan, it has the estimates. So then how am I getting this, right? If I look in the plan cache, all I can see are estimated values. How is it that in this case, I also see actuals? It's because I'm running 2019, and it's because I turned on a specific option. So let me come back to that, which is this: alter database scope configuration, set last query plan stats on. So I turn that on, and then I'm specifically going over to this DMV, DM exec query plan stats, which is going to be new in 2019. Okay? I find that to be really useful in terms of troubleshooting. Or I think it's going to be really useful in terms of troubleshooting. So I am going to credit Hugo in advance here for the idea behind this slide. Just to make sure that we're all on the same page. Across the top are what I have been calling the plans, so that you and I are on the same page today. But I want to make sure that we're clear on what else you might hear it be called just in case. So what you might hear it called, what information it includes, is the query actually being executed, where you get it, and what version. Okay, so this is a good reference slide, right? So when we talk about the estimated plan, you'll hear other people call it the estimated plan, right? We're getting that from Management Studio or Azure Data Studio. It has just our estimated values. The query's not actually executed, and that's available in all versions. What I call the used or the cached plan, you will hear called the estimated plan. I think that's confusing. That's why I differentiate between the two, right? This is the query that was executed. This is the plan that was used on query execution. It only has estimated values, but the query was actually executed, and you can find that in the plan cache. You can find that in Query Store. That's available in all versions. It's available in Query Store in SQL Server 2016 and higher. Then we have the actual plan. It's the estimated information along with the actual runtime statistics. That query has actually been executed. That you can get from Management Studio or Azure Data Studio or Extended Events or Trace. And available in all versions. Extended Events is 2012 and higher. And then we have our live query statistics. So the execution plan with live runtime statistics as we're executing the plan. And it's the actual values as they're happening. So this isn't something that I turn on for my fast queries typically. This is when I have a query that's running really poorly and I want to see where it's getting stuck in the plan. The query is actually being executed because you're running it from Management Studio. And that's available in 2014 Service Pack 1 and higher. And then we have the most recent actual plan. So you might also hear that called the execution plan with runtime statistics. It includes the actual values along with the estimated values. The query's actually been executed, right? It's the most recent execution. That's in cache, in a specific DMV, and that's only 2019 and higher. Okay? So again, I'm crediting, I want to make sure Hugo gets credit for that, who, according to Hugo, Brent also had suggested that to him. So it's a nice way to kind of understand or to compare the different types of plans as we're talking about them. So now that you know where to grab them, and now you know some of the most important things to look at, a few more details. You saw that we looked at the XML in the plan. I don't know about you, but I don't love XML. Now, if some of you are developers, you might be cool with XML. You might love writing XQuery. I am not that person. But there's a lot of advantages to those plans being in XML format. First of all, because they are in the plan cache and because they can be found in Query Store, you have the ability to programmatically parse that information. Maybe I want to look for patterns in my plans. Maybe I want to find all of my plans that have missing index recommendations. Maybe I want to find all of my plans that have a cost higher than some number, right? That definition, the XML schema, that's available. Every time there's a new release, there's a new schema that's listed. It's a really great place if you want to start digging into plans and finding more information. But again, you're going to have to go against XML to pull the information out. So what information do we have in a plan? Because we don't have everything, right? We know what tables, what objects are being accessed. We can see whether we do a scan or a seek. We can figure out the join type, what operators are used. We get estimates in terms of cost. We get number of rows. We get a ton of detail. We just start looking at the graphical version, but we then dive deeper by looking at the properties of the plan. What we don't get is query duration, and I have an asterisk there because it depends on what version you're running. We can get operator level statistics about duration, but I also tend to use set statistics time if I'm using Management Studio to get query information and duration. I/O information, again, it depends on what version you're running. They've done a great job, particularly since 2012 and higher, of adding more and more information to the plan. And so we also get operator level I/O information. But I use set statistics time a lot. We don't get anything about locking in our plan. We don't get who ran the query. We don't get from where they ran the query. We do get wait statistics information. That's in 2016 SP1 and higher. But I have an asterisk there because it's not entirely reliable. I would take that with a little bit of a grain of salt there. And we never get the actual cost of a plan or of an operator. And understand that you can't use these plans in isolation, right? You've got to get other information in terms of your tuning. But the plans are a really good place to start with understanding what SQL Server did. Now, how do we read plans? And what I mean by read plans is, do we read from right to left? Or do we read from left to right? How many like to read from, how many think right to left? That we start here and we go over? A lot of you, okay. How many think it's the other way? Not so many. It's all right. You're both right. What's really important to understand about these plans is that the operation really starts on the select side. It starts on the left. But the flow of data starts on the right. There's a really good blog post by a gentleman named Brad Schultz, which is called A Second in the Life of a Query Operator. And someday I'm going to act that thing out, because he wrote it like a play. And he has every different character for the operators. And the select query starts with the select operator. It's really easy to look at that plan and say that the first thing that happens is an index seek. But actually, it starts from the left side, and the control flow of what happens goes from left to right. But then the data flow starts on the left and comes back across. So when you're looking at the plan, it's very tempting to always start over here and come this way. And that's really useful when you think about how much data am I pulling across the plan. But the control, the order of what's going to happen, really starts from the left side, the select, and goes across. Now, to make sure that you're all still with me, when you look at an execution plan, and if you've never looked at an execution plan, you don't have to answer this question. But when you look at an execution plan, what does your attention go to first? Fat lines. I agree, right? These big, thick lines. And I will tell you, that's one of the first things that I always notice, because that tells me that I'm moving a lot of data across in the query. And my first question is that correct? Now, if I'm doing a select star and I have a lousy predicate or no predicate, okay. Or if I do a select top 1 million, that's one of my least favorite things to see ever. Why do I want the top 1 million? Okay? I looked at one of those today, actually. But the first question I ask when there's a really thick line like that, how much data am I expecting to come back? What else do you look at? Percentages. Okay, so your costs, right? What else? Exclamation points. So where are they up here, right? The little yellow triangles with the exclamation point, it's a warning. Sort warning, a hash warning, conversion. What else? Yes? Heaps. Because all heaps are bad, right? No, come on. Are they all bad? No, it depends, right? Had to come up at least once. A scan versus a seek. Because all scans are bad? No, right? But you're great, right? This is great. There is no magic right or wrong, okay? That's really important. And it's really, you may hear, you should never see a scan. You're going to see scans. What you have to think about is this what I expect to happen here? If I don't have an index to support a query, then it's going to scan. And just because I have a seek doesn't mean that that's necessarily ideal either, or that it's doing exactly what I think it's doing. So we really want to think about the patterns that we're going to see, and is that what we want to see? Is that what we expect? Reading execution plans is just like anything else, right? In order to be good at it, you have to do it. And what will happen, depending on your environment and your solution, you'll definitely tend to see patterns. If you stay in one place, in one environment for a while, you will absolutely see coding patterns. Excuse me. Execution patterns in your plans. Now, a note about cost, since you all mentioned it, right? Every operator within your plan is going to have a cost associated with it, and this is calculated during optimization. And the thing is that cost is always an estimate. Now, I agree that it's something to pay attention to in a plan. But remember that it's an estimate, and remember that it's kind of baseless at this point. In that cost, back in the SQL Server 7.0 era, and in what year was SQL Server 7.0 released? 1998, right? So back in 1998, cost equated to how long it took to run a query on Nick's machine. Okay, that is not the type of hardware we're using today, right? So cost at this point is unitless. It's not duration. It can be helpful when we're comparing different plans in a batch like we did before. It can be useful when we're looking at different operators within a plan. And that cost, remember, references goes back to cost threshold for parallelism. This defaults to a value of 5 for your instance. I'm thinking most of you have probably changed it to a value of 5. How many of you said, I'm going to set it to like 25 or 50 because that sounds like a good number that I read somewhere on the internet? Because Kendra Little told you to do it. Okay. So I definitely think that cost threshold for parallelism should be higher than 5. Because back in 1998, 5 seconds was a long time for a query to run. But hardware today is dramatically different. So if we leave cost threshold for parallelism set to 5, when SQL Server evaluates a query and comes up with the cost for that query, if it's less than 5, then it would be single-threaded. If it's greater than 5, then it becomes a candidate for parallelism, right? Now, there's actually a sweet spot in a lot of environments for queries that should be single-threaded and queries that should not be. 2550 is a general starting point. Did you know that you can actually query that plan cache to figure out what the cost is for your queries that are running parallel? And that's what I would recommend doing. So my colleague Jonathan Cahias, he's got a great blog post. I'll make sure to include the link, which has the code. You don't have to write the X query, which goes in and interrogates all those plans and says, OK, all these plans that are running in parallel, what's the cost? And so then you can adjust that cost threshold based on data. Not that I don't love and trust Kendra, OK? But no matter what, when you execute that plan, the estimated cost is always an estimate. You never see an actual, even in an actual execution plan. So we talked a lot about our operators. And these are fundamental components within our plans that we look at. There's over 100 different operators. I'm going to try and get through as many as I can. Come on, I'm kidding. No, you'd be so bored. We're only going to focus on the important ones here that I think you need to start with. Every operator has specific functionality that it is going to do, right? Some of them are data access operators. Others are going to join data or manipulate data. You're going to hear people say that this is a good operator, this is a bad operator. And again, what's the context? What am I expecting? What do I want to see? There are certain scenarios where the operator that you get is actually the best one, even if it has a negative connotation maybe that you've heard of elsewhere. So in terms of data access, I'm just going to introduce these, again, because Bert's going to pick up on this. So we have a table scan, which is when we're talking about a heap, right? A table that does not have a clustered index. A clustered index scan. We have a clustered index seek. We've got a non-clustered index seek, column store index scan, and also key lookup. So when I talk about data access, I mean that we are pulling data from a table or an index, whether we seek, whether we scan, whether we do a lookup. And most of our queries have more than one table in them, right? So we also have an RID lookup, right, for our heaps. Most of our tables, or most of our queries have more than one table, so we have to join based upon some column or columns. So when we talk about our joins between objects, we have our nested loop, we have a merge, we have a hash match, and those were the three for a very long time, but we also have the new kid in town, which is our adaptive join. So I want to talk a little bit about the first three, nested loop, merge, and the hash match, to kind of understand what's happening with each one of those and what you're expecting. And I'm going to use donuts as an example, because for the past couple days, I've talked about Top Pot, which is a donut place here in Seattle. And if you haven't been, I highly recommend going if you like donuts, okay? So we're going to work with donuts as an example today, because I really love junk food. And let's assume that we're interested in figuring out who ordered what donut and where they are in the building, okay? So we're going to pull back our name, we're going to pull back our location, and we're going to pull back the donut type from our donut info table, joined to our person info table based on our name. So what this looks like in our tables, right? We're going to first work with a SQL skills example, right? I'm in town, I'm visiting, and so I get a box of donuts for the team. So I have a list in my donuts table of what our donuts are, and this is based on the order they are, right? So we have chocolate sprinkle, cinnamon, sugar, blueberry, pink rainbow. I couldn't quite get it to look like a table. Work with me here, right? Pink rainbow sprinkle, maple old-fashioned, chocolate glazed. And who wants each one of those on the team? And then I have the location, right? We're here in 6E. Glenn's over in 6B. I don't think Jonathan's here, right? Maybe he's over there, right? Paul, Kimberly, and Tim. So if we talk about a nested loop, the way that the nested loop works is we would say, okay, we've got chocolate sprinkles for our donut here, and that's the one for Jonathan. And in order to figure out where Jonathan is, we have to go over to our other table. So we can see that in the other table, when we join based upon name, we find Jonathan's name, and we see that he's in 6B. And so that chocolate sprinkle donut should go to Jonathan in 6B. And then we go down the list, and we go to me. And I also wanted a chocolate sprinkle donut. And we come to our other table, and we're joining based on my name here in 6E. So that chocolate donut should come to me in 6E. And we're basically looping through. We go into the donut table, and then we take the one row out that matches, and we go over and we find the corresponding row in our name table, and we pull out our match. Right? That's our nested loop. Now, it's kind of selfish if I just bring donuts for the SQL skills team, right? Y'all might be a little upset. So instead, we have a whole bunch of donuts, right? And even though they're not quite organized in this picture that way, but we brought a whole bunch of donuts for everybody here at the conference today. So we have a list of the donut and who ordered it. And then we also have a list of our people and what room they're in. Now, what would happen if I did a nested loop here? It's going to be just like my query, right, where it went through over and over again. We'd have to go one at a time. We'd go to chocolate sprinkles for Jonathan, and then we'd have to go into the bottom table and find his row. And we would work our way through it. And a nested loop for a large data set is not optimal, right? A nested loop is great for a smaller data set. But if I've got hundreds of thousands or millions of rows, I'm not expecting to see that there. What I probably want to see instead is what's called a hash map, or hash join. So with a hash join, it typically occurs when we have large sets of data. And we're going to take this table, and actually what we're going to do is we're going to generate a hash table from it in memory, and we're going to bucket what we are joining on. So remember, we're joining on name. So there's a build phase where the optimizer goes through that top table, and it says, OK, we're joining on name. So I'm going to put all these names into different hash buckets. And once I've done that, and understand it has to do it for all of the rows in that object, then we're going to go through the bottom, and we're going to find where the bottom row goes. So Erin Bertrand, he's got a chocolate sprinkle, and that's where he goes. So we have this build phase where we're putting everything from our top into the different buckets. Right? We're hashing based on that name column. And then we go through the probe phase where we take that bottom input and find any matches. The thing about hashes is it's called a stop and go operator, because we have to build that table before we can start going through. The nested loop, rows keep streaming across. But in the hash, we have to go through that build. And so we have to wait for that to happen. And on top of that, that build happens in memory. And so SQL Server has to estimate how much space it's going to need. So every time you see a hash map, understand that behind the scenes, there's a memory allocation that occurs, which is we're allocating memory for this hash. And if it estimates incorrectly, what can happen? It'll spill, right? So sometimes if you see a hash and you see the triangle with the warning sign on it, it means it's spilled. It was thinking it was going to get 5,000 rows, and instead it got 500,000 rows. Okay? So you might hear that a hash is bad, right? Sometimes the hash is what you need because of the large data set. What I like to see with larger data sets is a merge. So imagine that we have this huge donut order for everybody here at the conference. And rather than having these two tables ordered in this fashion, where we have our ID and our donut and our name in the top table, what if instead we had it ordered by name? So we had a list of what all the names were and what type of donut they wanted. In this scenario, what we can have happen is we can do a merge. And the merge only works when both data sets are ordered. So Erin has a chocolate sprinkle, and we can see there's a matching row in the bottom. So those two match. And we send a chocolate sprinkle donut to Erin in room 6C. And then we basically just work our way down the list, right? Erin C has a Bavarian cream filled. He's in 6B. Those match. We pull that across. We come to the next person, and we don't have a match for that person in the other table. So we don't return anything for that individual. We go to the next Erin in the list, apple fritter, matches over to 6B, and it comes on through. So a merge has less overhead than a hash. It's a little bit more than a nested loop, and one of the things to be aware of when you have the merge is depending upon what your input is, of course it always has to be ordered, but whether or not it's unique, you can have work tables being generated in the background. But for the merge, you always have to have that data ordered. So let's take a look at what these look like within our plans. Okay, I had a lot of windows left open. Let me close all of these. Don't want to save any of my plans. I've got them somewhere. And let's look at our joins. So I'm going to switch over to an upgraded copy of AdventureWorks for this one. And so for our first query, we're going to look at sales order detail and sales order header. And we're joining based upon our order ID. And we're looking for a particular customer ID. So if I run this query, and I'm going to make sure that I include the actual plan here. And I got to make sure I'm in the right database. Right? And I look at my plan. Here's where we see our nested loop. So we see a seek against the sales order header. And then we have, so basically we're going to pull a row out of sales order header. And then we're going to look for a matching row over in sales order detail. And we're going to loop through that result set. So here, right, our predicate was customer ID equals 29712. So as it finds a row for 29712, then it's going to go over the other table and find the matching row and send it across until it finds no more matching rows, and then it's done. Now what happens if I reverse the order? So here I had from sales order detail by sales order header. And if you look at that nested loop, sales order header is what we call the outer table for that nested loop because it's a really small result set, right? It's only 8 rows. But what happens if I say, I want you to force the order here, which means maintain the order of this particular join. So when we run it this way, we get something different, right? Sales order detail is on top. And we pull, what, 1 million rows out of that table? And it changes the join entirely. Rather than doing a nested loop, it decides that's really inefficient. It's going to do a merge join instead. So whenever you see a nested loop, one of the things that you should be looking for is you want to look for that small result set across the top. In this scenario, I've got 1 million rows coming across. And then you can see I've got a smaller amount of data that comes across here. Right? That's a red flag. And that's only, and if that were a nested loop, that would be a red flag. But it said, I'm not going to, you asked me to keep the order, so instead of a nested loop, I'm going to do a merge join instead. Now, if I say, no, I really like the loop. I want you to do the loop. And I also want you to keep the order. We can force that to happen. But it's not going to be pretty. We get the same plan shape as before, but what do you notice that's a little bit different? It went parallel, right? So we get our nested loop, but the cost to do this was a lot higher. And if we run all 3 of those variations together, let me do that, hold on. And pay attention here at our plan, right? You can see up here, the cost for that first one relative to the other 2 is 0. The cost for the second one is 6. When we said, no, I want the nested loop and we're going to force it to be the one table on top, it goes up to 94. And if you hover over here, you can see the specific cost, right? Here we have 0.025. Here it goes up a little bit, right? Our merge is a little bit more expensive. But if we come down to the bottom one, right, 19. And I left, by the way, cost threshold for parallelism at 5. So because it exceeded 5, it's 19, it went parallel. One of the things to pay attention to also is when you have a scan on the inner table. So this is a slightly different query, which goes against product and sales order detail for a particular product ID. And notice what happens here, right? Typically, when you see a nested loop, down here, you typically see a clustered, you see a row ID lookup, right? Or a lookup against a clustered index. When you see something like a clustered index scan, that means that every time it's going down there, right, it is scanning. So that's a red flag to watch out for when you're looking here. Now, I have a missing index recommendation, so I could probably create that index and resolve this, because we're against, which table does I want to put it on? Probably against my detail table, right? Product ID and order quantity, so that I wouldn't have to scan that table to retrieve that information. So I have these two tables. I have sales order header and sales order detail. And I'm going to turn my query plans off. And if you've never used Kimberly's SP Help Index, I highly recommend taking a look. It's got a lot of great information that you don't get just from SP Help Index. It has information about not just the index key, but also the included columns. So I'm going to mess with some of this data a little bit, but understand that for both of these tables, we have clustered indexes. And then we also have a few non-clustered indexes. And for all of these tables, there's sales order IDs, and they exist in both of them. There's no exceptions where we have a sales order ID in one and not in the other. So if we turn on our actual plan again here, and we look at a good old query against those two tables where we're joining on sales order ID, and I don't have any kind of a predicate, which is very sad, right? And we look at this execution plan. It's returning enough data that it decided it's just going to do a hash match. Now, it wasn't expensive enough to go parallel, but it does scans against both objects and has to do a hash match because it's not ordered. Or if it is, or it's not ordered based on both of these columns in those tables. So what happens if I create a copy of these tables? So we're going to create a copy of the sales order header table. Ooh, I left it in there. Let's clean up real quick. Did one of them exist and not the other? OK, they should all be gone now. So let's create that table. And we're going to make sure that we have a primary key and that it's clustered based on sales order ID. OK, so it's going to be ordered by that. And then we're going to create a copy of that other table, which is also going to be ordered based on sales order ID and then also sales order detail ID. So now when we run our query, but we've ordered the index in reverse. I don't know if you noticed that. I did a descending on that instead of an ascending. If I run that same query again, but against the copy, where I have one table that orders sales ID this way, and I have another table that orders sales ID this way, what's going to happen here? So the thought was that it's going to do a hash or it's going to push a sort in there so that it could do a merge. Well, it actually did a merge as it was. So this is kind of fun. If we look at the properties of this, we can see that against the sales order header table, right, it read through that index. And if we look against the sales order detail, we can see that it read through this as well. But what's kind of fun is that somewhere in here, it should tell me the way that it read through the table. And I am in the full properties. Oh, I got to go down, don't I? There we go. Thanks, Hugo. I need to scroll. So here, I can see that my scan direction is forward, so it read forward through the index. In this one, it read backwards through the index. Because, as Bert's going to talk about, indexes are basically just linked lists, which I can read through in either direction. So I didn't have to interject a sort. But if they were not ordered, and I was trying to get a merge join in there, remember the merge join means the data has to be ordered by the join column. So it can sometimes put a sort in there. And that's something that you definitely want to watch out for. Now, if I take my constraint away, so basically I'm saying you're no longer a clustered index, right? I'm getting rid of that entirely. Now what are we going to see? Now I see a hash, because the data against sales order header is no longer ordered, right? It used to be ordered by an ID, but now it's not. It's just a heap. So in order to do any kind of evaluation, I'm going to build that hash match. Taking that data, pushing it into a sort, and then a merge join, it says it's too expensive. I'm going to see a hash here. So if I wanted to tune this, if I wanted to make this better, well then maybe I'd put the clustered index back on that table. And if I force it, if I say, same query, tables in the same definition, but now we're going to say merge join. You have to do that. Changes the shape slightly. Notice that it goes parallel. And here, we get that sort injected. So it reads everything out of that heap, and then it sorts the data. And the thing about sorts is they're expensive. A sort is also a stop-and-go operation, because it's taking all that data from the heap, and it's pulling it in, and then it has to get it into a particular order before it can pass it along. Right? So my image for this, my visual, hang on, is my daughter's Halloween candy. Right? What do kids do the moment they get back to the house with all that Halloween candy? They dump it out, and then they sort it. Right? Now, my kid does not sort it like this. Right? But I made her, just for my picture's purposes. Right? I'm like, this is great. Right? They sort them into different piles. But if this were my heap that I were reading through, in order to use that merge join, I have to order the data. And in order to do a sort, SQL Server needs memory. How much memory does it need? It's going to base that off of the estimate. What happens if the estimate's wrong? It's going to spill. Okay? So when we talk about hashes, when we talk about sorts, when we're looking at those in the plan, we're looking to see, is that spilling? Do we have enough memory allocated? And if we don't, then maybe we have an issue related to our estimates. I'm not just saying you should go update statistics, okay? But somewhere, the Cardinality estimator doesn't have a good idea of how much data it needs. So I think I said all of this. Don't have them in quite the right order. Now, if you see a sort in a plan, maybe you need an index to support that query. Maybe you don't need the order by. I say this because is it possible, rather than ordering the data on the SQL Server side, is it possible to order the data client side? Or if you have a caching tier in between, can you order it there? Right? It's a valid question. It's particularly valid when you have an application that allows users to sort data in different ways, right? User A can sort by one column, user B sorts by a different one, user C sorts by like 3. So when SQL Server tries to handle that, trying to index for that is really complicated and creates a ton of indexes potentially. So when you're asking for data in a particular order, ask where the data has to be ordered or where it can be ordered. So a couple other points that are worth mentioning in a plan, right? The compiled values, I showed you where to find those by going into the properties of the plan. Anytime you have a query that has different plans, and you can really see this within Query Store, Anytime you've got a query that has different plans, one of the first things that I start to look for is what are the different values that it used for compilation. So here, right, for this store procedure that we looked at before, I should have 2 different plans in here, but I don't, because I didn't run it in both ways. But I want to look to see what were the input parameters used for compilation. And again, if you go into the properties, you can find that. Missing index recommendations. I don't want to go just create all of them, but I want to start to do some analysis. Cardinality estimator version. This is also in the properties of the plan. So when I come in here, let me hop back to this one, and I bring up my F4, and I go to my select. Right? I can see cardinality estimator model here. 70 is old, and 120, anything higher, is going to be a newer model of the CE. Okay? This can dramatically affect plans. Anybody who's upgraded from something to 2014 or higher has probably run into issues related to the cardinality estimator. We look for the warnings. We look for the yellow triangles with the exclamation mark. If I see parallelism, is that what I expect to see based upon the particular query? Or is something happening that maybe shouldn't be? Am I pulling too much data across? I have operator execution statistics. I also have information in a plan about trace flags and whether or not I have data type conversions. And I think John's going to talk more about data type conversions. And this is just the beginning, right? We had 75 minutes to talk about plans. We can talk about it for an entire day. So I'm hopeful that this gets you started. I have a list of resources up here. And as a reminder, in the developer learning pathway, Bert is up next. And then Jonathan is teaching tomorrow. So I have a couple minutes where I can probably take questions while we switch. But otherwise, make sure that you fill out evaluations. And thanks for showing up today. Let me know if you have questions.